Alright guys, sorry I can't be there today, but I just want to talk to you very quickly about a special shape called a parallelogram and talk to you just about some of the properties of it. And so this shape here, A to D to C to B, kind of a weird order for me to go in. Maybe A, B, C, D, and then back to A makes a little bit more sense. Anyways, this shape is called a parallelogram. And by definition, a parallelogram is a quadrilateral, so 4 sides, made up of 2 pairs of parallel line segments. So these 2 sides are parallel, that's what these arrows show, and these 2 sides are parallel, that's what these arrows show. So that's what makes this a special parallelogram, or a special quadrilateral. Other examples of parallelograms would include rectangles and squares, and a rhombus, if you're familiar with that. But anyways, it's a nice shape. It has some nice rules that work for it, and we're just going to cover those rules really quickly now. The first rule is talking about the opposite sides of a parallelogram, so like AD and BC, or AB and CD. What we know is that obviously the opposite sides are parallel, but they're also congruent. Maybe we have this symbol here for congruent as well, which means that they're going to be the same. So for example, if AD was 14 inches, I would know for a fact that BC is also 14 inches. So I could put a little mark on there to show that those are congruent. Maybe I know that CD is 8 inches, well, then so is AB. It's also going to be 8 inches. And so I could mark that those sides are congruent as well. They don't all have to be the same, all 4, but all the opposite ones have to be the same. Okay, so opposite angles. These are the angles that are across from each other here. So B to D and A to C. Now, it might be pretty clear from looking at this, at least, if the diagram is good, that B and D both appear to be acute, A and C both appear to be obtuse. And in this case, that actually will be the case. The opposite angles have to be the same, to be congruent. So B and D could be the same. They could both be, if this is, say, 30 degrees, then so is D. That's going to be 30 degrees as well. C and A are also the same, but not necessarily the same as B and D. So maybe this is 150 degrees. That would mean that C is also 150 degrees. The opposite angles, just like the opposite sides, are going to be congruent. They're going to be the same. So once again, you might see this symbol for congruent, but that's all you need. So one thing you might have noticed from the last one actually is that there's a connection between the angles that are next to each other, and it comes back to parallel lines and transversals. These are in a sense kind of consecutive interior angles, which means that they're actually going to be supplementary. So if I know that B is 80 degrees, then A would have to be 100 degrees so that they were supplementary. They have to add up to 180 degrees. Similarly, I could say that A and D are adjacent angles. They're the angles that are next to each other as opposed to across the way. So those 2 angles would have to be supplementary, and so that's why that's going to be 80 degrees right there. And I could use either the angle at D or B to figure out that the angle at C would be 100 degrees. And as a matter of fact, that just confirms my other point that the opposite angles are going to be congruent. So once again, just another property, pretty straightforward. Okay, so this last property is probably the trickiest one, and it's about the 2 diagonals in a parallelogram. The diagonals go from one angle to the opposite angle, so from A to C and B to D. They go diagonal through the figure. Now, they bisect each other, which means they cut each other in half. So there's a couple of different ways we could look at that. One thing might be that I know that from A to, let's call this point in the middle here, E. Maybe I know that from A to E, that distance is 10 inches. That's going to tell me that from E to C is also 10 inches. They're going to be exactly the same. And so that's one way I can show that those two sides are the same, or those two parts of the diagonal are the same. The other possibility is maybe I know what the entire thing is. I know all the way from B to D, for example, is, let's call it 30 inches. That would mean that each part is going to be half of that. So I'm going to have 15 inches from E to D and 15 inches from B to E. And so these two sections there are the same as each other. And that's pretty much it. That's the property. So you know these properties now. You can apply these properties if you're given numbers or if you're given algebraic representations with variables and constants, and go from there. Okay, hope this is helpful.